Okay, what we're going to do today is we are going to do overloaded methods. So public class overloaded. Overloaded methods are pretty cool. So we'll just start off with our regular main method, public static void main string args. And let's suppose we actually have this as a class, and so I'll have int I, and then I'll have int j. And then what I'll do is I'll just have a constructor. So overloaded ol1, that's really, I'll just say ol equals new overloaded. All right, we should probably have a constructor. So let's have a constructor here, public overloaded. And we'll start off with, we'll say int I, and then int j. And this dot I equals I, and this dot j equals j. Okay, so as a review, what is a constructor? A constructor's purpose is to figure out how to set up the instance variables. Instance variables. The whole point of instance variables is, why do you actually have this object? Well, this object called overloaded has an I and a j, and it has two ints. That's the whole point. You'd have some getters and setters, also called mutators and accessors, and then you would do something special with this I and j. And the constructor does not have a return type. That's the main difference between the constructor and a regular method. Now, let's just suppose that we, in this class, only want to be able to have positive values for I and j. So we're going to make this private, so that we can't directly access it. So if we do like, say we create a 3, 4, that should be happy. Yes, I will save it now. Compiles fine, it runs fine, but I can't directly access I. I can't say ol.I equals, say, 5. No, it won't work. Actually, it does work because I'm in the same method. All right, what I'm going to do is I'm going to take I'm in the same class, and so private, it works inside here, so I'm going to take this main method out, and I'm going to call this public class main driver. So the main driver will be driving or using the other class we've got here. All right, save, compile that. There we go. So I has private access. So here in overloaded, I cannot directly access I. So I have to have my setters and getters. So that makes sense. So the public void set I, you pass in and I, and you simply say this dot I equals I. This refers to the instance variable. The other I is the local variable. Remember the scope. And then I'm going to do the same thing. I'm going to say public and get I. Oops, not get it, but that's funny. Get I, and then it'll return I. Or I could say return this dot I. This is the exact same thing. Since there's no local variable, it's referring to the instance or global variable. And I will copy this, and I will simply change this I to a J, and this I to a J, this J, J, and now the get I will be get J and a return J. Everything should be happy. All right, so I now have a way to access I and to change I. So, compile that. That's good. I still can't directly access I because of the idea of encapsulation. Everything is private here. Oh, wrong one. Everything's private. So it's going to be I dot ol dot set I, and then I would pass in 5. All right, that works out. Yay, I can do it. And then I can do system.out.print ol.get I, and then I'll put a comma here, and then ol.get j. All right, and then it should return ij, which used to be 3, 4, now it can be 5, 4. So I compile that, and I run that, and there's my 5, 4. Pretty cool. But what about if I, oh, wrong one. What if I only want to be able to set I to, if it's positive? So I am going to initially set I. In fact, how about this one? When I try and set I, if it's not positive, it will be, I'm going to set it to 0. Okay, so if I, that's the local one, the one that we're passing in, is greater or equal to 0, then I'm going to say whatever they pass in is fine. Else, I'm going to say I equals 0. So if they attempt to change I and it's below 0, I'm going to set it to 0. That's what I'm going to do. So 5, this should still work fine because 5 is greater than or equal to 0. Works. I'm going to change this to a 0, and that should set it as a 0. I'm going to try and make this -10, and that should set it to a 0 because that's just what I decided to do. And that did not work for whatever reason. So if I is greater than or equal to 0, I'm going to set it to I. Otherwise, it's that. Did I compile it? There we go. Okay. What is weird? Oh, that is really funny. Do you see the mistake I made? This is setting I, the local I, to 0. But I want to say this dot I equals 0. All right, and I go back here and run that, compile that, and it actually does work. So that's actually a really good example of a scope mistake, because without the this dot I, it was setting the local variable I to 0. Okay, that was an embarrassing but good example for you guys. If I was a liar, I would say, yes, I meant to do that, but I didn't, so all right. Okay, so this is a review all about encapsulation, and let's go in here and think about this a little bit further. What's one way I can break it? If I set this, because I can actually break this, so if I have 3, 4, that'll work out. But if I set this to be a negative at the beginning, yeah, it'll still be negative, which is bad. So if they create something with a negative I at the beginning, uh-oh, it's going to be negative. So what I need to do is come over here, and instead of, when they pass in I need to actually pass in set I, and simply go like here. And now, there's really, really only one place I ever get set, and this is right here. And this is really important because if there's ever a bug, like I just had, I had I equals 0, I know exactly where the only place is where I made the mistake. There we go. And so I try and pass in a negative number, but it's going to be a 0. Yep, there we go. We got the 0, 4. Very good. So we now know what a constructor is. It's what sets up the instance variables in the object. But I can have more than one constructor, so I'm going to have overloaded. And let's suppose they didn't have anything. They simply have overloaded and they pass in nothing. Well, what I can also do, and this is going to be really weird, I can just say this and then pass in 0, 0. Well, this, when I say this.I, it refers to the instant variables of overloaded. When I simply call this as a method, it calls a constructor. Well, what I'm doing is, if they don't pass in anything at all, I'm saying that's fine. I'm going to call this constructor and pass in a 0 for I and a 0 for j. That way, if they don't pass anything, it's still going through this one method. So everything goes through the same funnel. And why would I have two constructors? It's to let the person, who happens to just be me right now, but if other people were to use this, it would let them use this and have more flexibility. There we go. I can do that. And if I print out OL2 right here, it should print out 0, 0. There we go. Good. I can also have regular methods that are overloaded. Like I can say public string, and I might say the toString, and that simply returns, maybe I'll return I plus comma j. And that looks pretty good. .toString, I like that one. So I might have instead system out println ol dot toString, and I'll comment these out. And instead of me having to create it here, I comma j, it'll create it for me, because in here we've got the I comma j. It's already formatted correctly and it's nice. So then when I do this, ol2string, it doesn't like me because it doesn't, it's not a method. I have to have parentheses. There we go. And run that. Hey, 0, 4. Nice. Well, what if I want a toString method without commas? Maybe I want a space. Then I'll have toString method, but I'm going to pass in a character, and I'll call that the separator. And then whatever the separator is, that's what's going to be put in right there. Maybe I'll even have the string as a separator, so I can have whatever I want. So this is kind of a neat idea. If it's just the toString, it has by default a comma. But otherwise, I can have a separator of whatever I want. So let's go in here, and I'll set up a number of different separators. This one, I'll pass in a colon, and maybe in this one, I'll pass in a cat, because I can put in whatever I want in there. So 0, 4, that's our default toString. 0, 4, put in there, and 0, cat 4. 0, cat 4 doesn't make any sense, but it is an example of why you might have more than one toString. So how does it know which toString to call? Well, it matches up the toString, TOSTRING, and it is a method, so it matches it up and it says, oh, okay, there's two candidates. If they don't pass in anything, there's no arguments here, so it matches with the fact that there's no arguments here with no parameters here, and it runs this one. On the other one, it has toString, it's a method, and it passes a string. So toString, which one do we call? The one that has a string, and then it runs this code. All right, so what have we talked about today? We've talked about the importance and use of constructors and overloaded methods.